If you've used a cell phone or GPS to find your way, you've used wireless communications. Wireless communications is the transmission of voice and data without the use of cables or wires. Instead of a physical connection, the data travels through electromagnetic waves. The groundwork for today's wireless networking was laid in the 1970s with ALOHAnet in Hawaii. ALOHAnet, essentially a wide area network, or WAN, relied on ultra-high frequency signals to broadcast data among the islands. The underlying tech of ALOHAnet helped fuel creation of Ethernet in 1973, and then the first wireless standard, 802.11. Wireless has been around for over a century, but in the last 15 years, it's changed dramatically. Now, all types of wireless applications and services are used by thousands of companies and consumers. In that time, wireless features have evolved from slow, simple data transfers at rates of only 54 megabits per second to speedy operations that require gigabits of data to complete. Each new generation of wireless communication creates more sophisticated capabilities. These capabilities, in turn, give users flexibility in how they access information and services. We're at a point now where people can connect to resources from almost anywhere using powerful mobile devices. And the technology continues to mature. That means people with wireless networking skills will be in greater and greater demand. Wireless certification programs, like those offered by CompTIA and Cisco, help people acquire the skills they need to support wireless systems. The future of wireless is exciting. But before we get into that, let's first look at how wireless communications work. With wired networks, a physical cable is needed to establish communications between devices. But with a wireless network, data is sent and received between devices over radio frequencies. So, wireless networks eliminate the need for dedicated wired cabling. Many types of devices and equipment use wireless communications. You've no doubt used cell phones, cordless phones, a GPS, and laptops with accessories like wireless mice, keyboards, and printers. Wireless networks generally include some type of radio transmission to send and receive signals across a specified range of electromagnetic spectrum. So, a wireless network might use the specific frequency band of 2.4 gigahertz, and that band is separated into different channels to reduce the risk of congestion. Data transmission is typically done with antennas, which you've likely seen on older radios and television sets. On a modern device, though, the antenna is typically a small piece of hardware embedded in the device. Different wireless networks serve different needs. Here are a few examples. Wireless local area networks, also called wireless LANs, use radio frequencies instead of wires to connect nodes along the local network. Wi-Fi is a wireless standard that uses wireless access points to connect endpoint devices on a wireless LAN. Wireless wide area networks, also called wireless WANs or mobile broadband, use cellular technology like 5G to create a wireless network over a large geographic area. Wireless metropolitan area networks, or wireless MANs, provide access outside office and home networks. Wireless MANs are larger than wireless LANs, but smaller than wireless WANs. Fixed wireless networks deliver last-mile internet connectivity to households and businesses. This is useful in rural areas without wired connectivity or where satellite internet is the only option. A wireless personal area network, or wireless PAN, is a type of network that uses short-range wireless technology. Think of a wireless keyboard, mouse, or headphones that use Bluetooth to connect with your laptop. There are other types of wireless networks, but these examples help show how wireless networking designs can be tailored to meet different needs. Let's turn now to cellular networks. A cellular network uses radio frequencies, sending signals from one device to the next through a cell, an area that contains a fixed location transceiver or a base station. For much of the 1990s and 2000s, two standards supported cellular networks: Global System for Mobile Communications, or GSM, and Code Division Multiple Access, or CDMA. GSM and CDMA each had its own access architectures that used 2G and 3G cellular specifications. But with the advent of 4G LTE, and even more so with 5G, the distinctions have diminished. Modern cellular networks are typically defined in terms of which generation of wireless standard is supported. Let's look at the most common types of cellular networks in use now. 4G LTE, or fourth generation wireless and LTE, appeared in 2009. 4G LTE cellular networks can theoretically reach speeds up to 100 megabits per second. 5G was first introduced as a technical standard in 2016, and carriers began to deploy it in 2019. 5G data speeds can reach as high as 20 gigabits per second with ultra-low latency, like 5 milliseconds of latency or less. 5G has fueled new business cases, including autonomous vehicles and sophisticated industrial control systems. And 6G, which will use higher frequencies than 5G networks with higher capacity and lower latency. Some vendors are investing in 6G, but it's not a functioning technology yet and likely won't be available commercially until around 2030. Even so, some predictions about what 6G will enable are intriguing. These include threat detection, health monitoring, and facial recognition. 6G is also expected to enable emerging tech like smart cities, virtual reality, and augmented reality. Ever since remote work exploded in the wake of the COVID-19 pandemic, we've existed in an environment where employees need high-performance access to network resources wherever they are. Wireless communications enable that connectivity. Here are the most notable benefits of wireless technology. Cost savings. Wireless networks can be less expensive to build and maintain than wired infrastructure. Wireless features. New wireless features, especially multiple input and multiple output, or MIMO, allow physical access points to serve more users, which also cuts costs. Mobility. Improved wireless performance now helps organizations take advantage of greater mobility, thus helping them redefine how they design offices and work groups. But wireless is not without its challenges. Challenges can include planning demands. It takes forethought to design the right strategy for wireless. Good wireless strategies must make sure access points and other components are set up correctly so users can reliably access the services and applications they need. This process requires a wireless site survey, which helps ensure adequate coverage and signal strength, and identifies possible sources of interference across the network. Security. A wireless network typically has many devices using it and many different types of devices, which expose the network to threats. Bad actors can target wireless vulnerabilities using various network attacks, such as spoofing or packet sniffing. Power consumption is another challenge because wireless network components require more power than wired ones. This means enterprises should replace their power over Ethernet switches and other infrastructure components to support the newest wireless standards. Finally, troubleshooting can get complicated with wireless. That's because users are distributed rather than all in one location. Plus, as previously mentioned, these users are often communicating over different types of devices. The terms wireless and Wi-Fi get tossed around a lot, but Wi-Fi is simply a subset of wireless communications. It's a type of wireless LAN that uses radio signals to send data from a wireless router to your device, like your phone, tablet, or smart TV. Wi-Fi standards use different frequency bands to transmit data, such as 2.4 gigahertz and 5 gigahertz. The latest Wi-Fi standard is Wi-Fi 6, or 802.11ax. The next iteration, Wi-Fi 7, is slated to release in 2024. Wi-Fi networks have their own security protocols that augment any network control and access policies already in place. These security protocols include wired equivalent privacy and Wi-Fi protected access, which work in different ways to help secure enterprise Wi-Fi networks. Wireless communications is a fundamental part of enterprise networking. Advances in Wi-Fi and cellular markets have practically erased the performance gap between wired and wireless infrastructure. That means organizations can now go wireless first and use wired networks on an as-needed basis. Wi-Fi 7, the next standard of Wi-Fi, will improve performance, increase throughput, and allow more devices to connect while cutting latency issues. That new standard will support a maximum throughput of at least 30 gigabits per second, 3 times the amount Wi-Fi 6 enables. For cellular, carriers are also working on 6G development. 6G's benefits will include low latency, like 1 microsecond, with throughput and capacity that exceeds 5G. As capacity and performance supported by these standards converge, Wireless communications will let users switch seamlessly between Wi-Fi and cellular. That means wireless consumers will be able to access the services, security protections, and resources they need no matter where they are.